So in this video, we'll look at the hard case, which is marked in the red color for the integral that contains the terms, which is the product of tangent x and the secant x. And both terms can have some exponents on top of them, where the exponent in general is a positive integer. And in the previous two videos, we look at the two cases correspondingly, and the easier cases are stated here. When n is even, we don't care about the tangent at all. When n is even, we understand that we can always use the u substitution tangent x to resolve the problem. And we have done a few examples on that already. And the second case, which is also quite simple, which is the case where both are odd. In that case, we can use the u substitution where u is secant x. And we also have done some examples on that. So the two cases here are solved. And please think about it logically. The remaining case which is not solved is the case where n is odd and m is even. And I marked it in the red color, which is the hard part. We haven't done it at all in the last two videos. So in this video, we'll try to clean it up. We'll try to give you some hints on how to attack such problems. And you see the power of the tangent is 2 and the power of the secant is 1, and it is belonging to our case where the tangent x has an even power and the secant x has odd power, right? So we don't expect a quick answer to that. Now, let's think about it this way. We have to try to change the form of the integral a little bit, maybe by using some famous trigonometric identity. For example, we understand that 1 plus tangent squared theta equals secant squared theta, right? So it means inside here, which is the tangent square x, by using this, we understand that it can be expressed as secant square x minus 1. And it means essentially we have to integrate secant cube x minus 6 dx. Now, let's see whether it's an easy integration or not. The answer is not, but let me pause a little bit. I would like to add a note here. The key note from this expression at the end is that the answer to this problem, where the power of tangent x is 2 and the power of secant x is 1, comes down to understanding how to integrate secant cube x and secant x. And both of these are not done in the previous videos, and these are usually the trickier cases. And the general note, I'll put it up here. General note is that the understanding of how to find the answer to an integral that contains the power of tangent x, which is even, and the power of secant x is odd, is equivalent to the question of understanding the integral of the odd power of the secant x. And let's try to figure it out. So I digress a little bit. Let's try to find the derivative of ln of tangent x plus secant x. And you can use a chain rule here, which means I can use the formula for the ln function first. So it becomes 1 over tangent x plus secant x in the bottom as the denominator. And as a chain rule application, you need to multiply to this fraction by the derivative of tangent x plus secant x, right? And the derivative of tangent x is secant square x. And the derivative of secant x is secant x times tangent x. Now, I hope you can see how we can cancel out some terms from the top to the bottom. You see, this one has the common factor, which is secant x, open bracket, secant x plus tangent x. It means what? It means, you see, surprisingly and coincidentally, we can actually cancel out this tangent x plus secant x from the top in the numerator to the bottom in the denominator, right? So it means, surprisingly, the derivative of this fairly complicated function is the same as secant x. And it means what? It means when we integrate secant x, we can write the answer as ln of tangent x plus secant x, right? Plus a constant c. And that's why this strange formula for the integral of secant x comes out in many textbooks in calculus actually. Now please keep it in your mind. That's a new formula that you have learned. So you see, for the first case, we have done it in the last page, where the integral for the odd power 1 for the secant x actually has a fairly complicated answer as a formula now. And the next step is to look at the integral for higher odd integers. So for example, let's try to integrate secant to the power 3x dx. So to be honest, it's not something very easy. We have to kind of try our luck. And there's a clever way of using integration by part if you observe something. Because the fact is that if you let u be secant x, if you let this one be dv, dv looks complicated, but the fact is that you can find v easily because it's a famous derivative, secant square x, right? dv to v is an integration, so it's just tangent x. By using these hints, I mean, you have to make a very good observation here. And u is actually secant x, and du is the derivative of secant x, which is secant x tangent x, right? So now I'm trying to use integration by parts. So the formula for integration part is uv minus integral of v and du. And let's write down all the terms together. So u times v is clear, which is secant x times tangent x, right? And minus the integral of tangent x, which is v, times du, which is secant x tangent x dx. And let's try to focus on this integral on the right hand side. So now you're having something like the integral of tangent square x secant x dx, right? So now let's think about it this way. We have to try to resolve it a little bit. So we can try to apply our famous identity here, which is secant square x minus 1, right? So which means the next step is what? The next step is secant x tangent x minus the integral of secant cube x minus secant x, the whole thing dx. I hope you see what I'm doing. Basically, I'm just distributing this factor secant x into both ends. And now it seems that we obtain a formula because you see the integral of this term is really the same as my original problem, right? Let me write down this formula here. So please look at the current updated formula. That was my question at the beginning, which is the integral of secant cube x. And you see the middle term here, is actually the same as my current problem. Now, please note that there are two minus signs for the second term of the integral become plus, and the last term is the integral of secant x, which we know already. There's a fairly complicated expression for that. It is ln of tan x plus secant x, right? So it means what? I can bring the two terms together by algebra. So it means we have the next steps. So please look at the steps that I wrote here. I'm pulling the minus I to the left-hand side, right? So now the left-hand side has got two copies of I, which is 2I, equals something in the right-hand side. So it means the answer we have for the integral of secant cube x is gonna be secant x tangent x plus ln of tangent x plus secant x. And we just have to divide the whole by 2. And that's the final answer to the secant cube x here, right? So you may be wondering how we can do the integration for sin x if the power is even higher and odd. For example, let's say the power is 5. And I claim that a similar method like this still works out. Please recall the process, how we can get this answer for the integral of sin cube x. We did a clever integration by part, and we also make use of the formula for the integral of the secant x, as you can see on this page now, which is the last term on the right-hand side, right? And at the end, we're kind of resolving it by reduction formula because both left and right side has the same term, which is I, which is the integral of secant cube x. And let's see what's happening for the secant to the power 5x. So I try to be slightly faster here because I'm trying to use the same strategy as how we did the secant cube x integration for the current problem. And once again, we have to use a clever integration by part, and u and dv are something like that, and u is secant cube x and dv is just secant square x. I chose it as dv because the v can be easily found, which is the integral of secant square x, which is tan x. And for the du, you have to use a chain rule, so it becomes 3 times secant square x. It is a power rule here, and you have to multiply to a chain rule term, which is the derivative for the secant x, right? And secant x derivative is secant x tan x, and we have to add a dx. It means what? It means the u is actually 3 times secant cube x times tan x dx. And let's use this as the hint for the integration by part. You have to tell me what is uv minus integral of v du, and let me write it down here. So please look at what you have on the second term on the right hand side. It is actually 3 times secant cube x times tangent square x, right? And once again, we have to make use of the identity tangent square x equals secant square x minus 1 for the tangent square x term. So the next step should become this. So you see the next term, we have the secant square minus 1 to represent the tangent square x term, right? And let's look at what's happening. You see on this integral, is actually we can distribute the 3 times secant cube x to the two terms on the bracket. So it becomes two terms inside integral, which is 3 times secant to the power 5x minus 3 times secant cube x, right? And now let's see what's happening. So it looks similar to last problem. You see, because this term, with the integral of this term, is actually my original questions, right? And which means I can represent I as the integral of secant to the power 5x. And the remaining integral is something that relies on your formula for the integral of secant cube x, right? And let me write down the formula. So you see, I'm letting I be the original question, which is integral of secant to the power 5x. And this term is the same as the middle term here for the I. And please note that we know this formula already for the integral of secant cube x. So we just have to replace the formula in here. And which means, you see, this minus 3i. This minus 3i can be pulled to the left-hand side. And it means 4i becomes what I've written down here on the right hand side. And please note that we have the formula for the integral of secant cube x already. You just have to replace that. And of course, you know the I now. You just have to divide the whole expression on the right hand side by 4, right? And that's basically the answer to the integral of secant to the power 5x. I'm not going to write the answer down. I trust that you're able to do that, because I'm just giving you the hint for this problem. And similarly, even for higher odd power, let's say the odd power is something like 7, 9, 11, etc. We can still use the same trick to solve all these problems, which you have the secant to the odd power. And as you can see, it's not very easy, but at least we have the mechanism to solve it. You always have to use a clever integration by parts, and dv should be the secant square x dx from the beginning of the problem. And gradually you can solve it by method which is very similar to these. And that's the end of this video.